Now, in this slide, you're not given the standard form of the equation of the circle. Instead, you're given the general form. Now, this is called the general form. Now, we want to find the center and the radius. So that means you have to change it to the standard. So we have to change it to the standard form. Now, sometimes the standard form is also called the center radius form because, it gives you the center and the radius automatically. Okay, we're going to slow down a little bit because, our class is a mix of ninth graders and 10th graders. And, I don't know if, the ninth graders discuss completing the square in their elementary grade. So let me write it down. I'm going to write it down here. We're going to use a process called completing the square. Now, if you're a 10th grader, we did this together with the methods in solving quadratic equations. Okay, so I'm going to slow down a little bit so we will all be at the same page. Okay, so what is completing the square? First, let's copy the original equation. So as you copy it, let's try to rearrange them such that those that have the same variables are together. I'm going to leave a little bit of space over here. So plus y squared plus 4y. And then I'm going to separate the constant. So this 16 over here, we're going to move it to the other side. So since it's negative, it's going to change to positive. Now, do we do this all the time? Or when do we use, this method? We use this method if we are given the general form of the equation of a circle and we want to find its center and radius. Okay, so what is the first step in completing the square? After rearranging them, you're going to look at the linear term, meaning the coefficient of x, not the x squared, that's the quadratic term. So this is the linear term. So the number here is -8. Get half of it. So half of -8 is -4. I'm going to write it down, make a little note over here. So -4, right? Now, you're going to square this one, like multiply it by itself. Okay, so what is -4 times -4? You get positive 16. You're going to add it over here. That's why I left a little bit of space. Okay, now let's do the same thing here. Get half of 4, or positive 4. So half of 4 is positive 2, right? So square that again. 2 times 2 is 4. So what did we basically do? We added 16 and 4, to the left-hand side of the equation. And since this is an equation, whatever we do to the left, we have to do to the right. So since we added 16, we're going to do the same thing here. So plus 16, we also added 4. So plus 4. Maybe you're wondering, well, how about the -4 and the positive 2? Remember, those are optional. Writing them actually is optional. So you could just think, oh, half of -8, is -4. You don't have to write it down over here. And then just add whatever the squared version is. So half of -8 is -4. You square that, becomes positive 16. Okay, so now what's next? And why did we have to complete the square? We needed to complete the square so we can rewrite the equation into its factored version. So in other words, you're going to write this in the form x minus something squared. There you go. Because remember the formula, it was the form x minus h squared. Okay, so if you factor this, let me have like a little discussion over here. If you were with me last year, remember the x method, like you get a -8 on top and then a positive 16 at the bottom. So that means -4 times -4 is positive 16, or if you add them up, you get -8, right? So that's why we got those, those little numbers over there that I wrote previously. So to factor that, we get x minus. Now why minus? Because the quadratic trinomial that we're factoring has a negative sign in the middle. So x minus, don't use the 16, use the 4 that I wrote on top. So in other words, use half of the number. So x minus 4 squared. Then plus, let's factor this again. That's y. Now, are we going to use a plus or a minus? Since the middle term has a positive sign, you put positive. And then what number do you use again? You use not the 4, but use the half number. The half number, the number that's 1/2 of the middle term. So plus 2 squared equals. Now add all these up together. 16 plus 16 is 32 plus 4 is 36. There you go. Now, this number sometimes, doesn't end up to be a perfect square number, and that's okay. As long as whatever you added to the left-hand side, you're going to add also to the right-hand side. Well, is it always addition? So if you take a look at this number, whether it's negative or positive, when you square it, it would still be positive, right? So squaring a positive or a negative number still results to a positive. Anyway, so going back here, this is now the form that we want. So can we identify the center here? Well, the center is now given by, that's your h, it's x minus 8, right? So this is 4. In other words, you take the opposite of those numbers. So that's negative 4 becomes positive 4, and then positive 2 becomes negative 2. Okay, and then the radius here is, this is your r squared version, so you get the square root of that. So r is equal to 6. Okay, then you're going to graph it, right? So you're going to place a dot at 4, negative 2, and then from there you count 6 in all directions, up, down, left, and right, and draw your circle. Okay, in this example, we're going to prove or disprove that the point root 2, comma, root 2 lies on the circle centered at the origin containing the point 2, 0. So how are we going to do that? Well, first it says the center is the origin, so C is 0, 0. Now, do we know the radius? No, but if we make a sketch of a circle, it's centered at 0, 0, and it contains the point 2, 0. So that means the radius is 2. Then you have another point right there, get the reflection over there. Okay, well, you can make a better version of this drawing on your notebook. Okay, it's hard to draw using this slate over here. Okay, so it's not a perfect circle, but okay. Anyway, so if we're going to write down the equation, it's x squared. Now, why is there no x minus h? Well, because the center is 0, 0. So x squared plus y squared is equal to r squared. We already know what r is. We figured out that r is equal to 2. So that's 2 squared, which is 4. There you go. Okay, so now how are we going to show that this radical 2 is, is on the circle, or how do we prove or disprove that? Well, let's substitute it and see what happens. If I substitute radical 2, I'm going to get root 2 squared plus root 2 squared is equal to 4. Well, we don't know yet if it's equal, but that's what we're trying to show. So, if you square a radical, the radical disappears. So this is 2. Do the same thing. So that's 2. And yes, okay, 2 plus 2 is equal to 4. So since the left and right hand sides of the equation match, then we know that radical 2 is on the circle. So how do we know whether a point is inside the circle or outside the circle? Well, all the points along the circumference, when you substitute them into the equation, they all equal to the radius, because by definition, all the points in the circle are equidistant from the center. So if you end up here with an answer that's less than 4, then you know that that point is inside the circle, right? But if you substitute it into the formula and it ended up to be like greater than 4, then you know that's outside your circle. So use your notes. I hope you took down some notes, some formulas, some new procedure that you saw in the 2 screencasts that I made. So you can use them as a reference to do your practice for this lesson. You can find them in the 10.7 folder. Let me see. Okay, so 10.7. Yep, so later on you'll do some exercises. You have to download the PDF version so you can write down the formula and write down your complete work. Well, unfortunately, this topic needs or requires you to show your mastery in writing down the equation, so I cannot do just a simple drag and drop activity for this one. So, oh, sorry, you can hear my little one in the background. But yeah, so for 10.7, download a PDF file. The exercises that are similar to the ones that I showed you. And then the practice version, which is your assessment for this lesson, will just be, writing the letter of the correct answer. All right, good luck.